All right, we are on page 4, notes 5.2. We will be talking about double or compound inequalities. Today in class, or the lesson I saw you in class, we talked about the difference between and or. And we discussed that the word and, means that both have to be true. If you have the word or, however, it means that one or both are true. Okay? So let's look at question number 1. Graph the solution set of x is greater than or equal to -2 and x is less than 5. So this means that both have to be true. So we have to find a number that is bigger than -2 and less than 5. Hopefully you can think of a number that would be bigger than -2 and less than 5. Think of a number and write it down. We'll talk about that number that you thought of in a minute. So what you're going to do is you're going to draw your number line, okay? So then right here, it's the lowest number I have is -2, so I'm going to go a little bit past -2 and I'm going to start at -3. And then I'm going to go all the way up into my larger number, which is 5, but I'm going to go 1 past it, so I'm going to go to 6. Okay? And if x is greater than or equal to -2, then I'm going to shade in this piece right here, and I'm going to put an arrow on top. I'm not going to shade it on the number line yet because I want to know what answers are going to satisfy both inequalities. So I'm going to see where they're going to overlap with each other. So I'm going to look for an overlap. That's really important. Okay? And x is less than 5. So I'm going to put an open circle on 5, and anything less than 5 goes this way. So this pink and this green are going to overlap with each other simply from this section to this section. So I'm going to shade everything in from -2 all the way to +5, including -2, but not including 5. Okay? So then this means that my answer will be anything from -2 to 5. And think of the number that you wrote down. Ask yourself, did it fit in this area? Hopefully it did. Anything between -2 and 5 should work. Now, I'm going to write this in interval notation. This means that my number starts at -2 and includes -2 and ends at 5 and does not include 5. So this is my answer in interval notation. All right, question number 2. Graph the solution set of -2 is less than or equal to x is less than 5. Well, the first thing I'm going to do is I'm going to split up my inequality, my double inequality, so I can see them separately. Now, if it's all stuck together, it means that both have to work, which means that it's an and problem. So my first inequality would say -2 is less than or equal to x. Then I have to say and, because it has to satisfy both of them. And my second inequality would say x is less than 5, which turns into the exact same question that we had in question number 1, because if -2 is less than or equal to x, that means that x is greater than or equal to -2, and x is less than 5. Okay, so we're going to say that it's the same as number 1. All right, so now let's look at number 3. Graph the solution set of -4 is less than x is less than or equal to 2. So I'm going to split this up. The first inequality that I have is -4 is less than x. And then the second inequality that I have is that x is less than or equal to 2. All right, so then when I do this right here, I'm going to have my number line right here like this. And I'm going to go a little bit to the left of my lowest number, which is -4. So I'll start at -5, and I'll go all the way up until I get to a little bit to the right of my highest number, which is 2. So I'll stop at 3, okay? And if if -4 is less than x, that means that x is bigger than -4. So that means that it would go to the right, okay? And if x is less than or equal to 2, I would put a closed circle right here, and it would go to the left, and my overlapping area would be in this area right here. So that means that everything from -4 to 2 works, excluding the number -4. So that means that in interval notation, I will end up having -4 with open parentheses, okay? And then all the way up until +2, and I'll have closed parentheses there, all right? Now, number 4, write the compound inequality without using and. then graph the solution set, okay? So what I'm going to do is first I'm going to take each one of my inequalities and I'm going to write them in order from the smallest number to the largest number. So x is greater than 0 and x is less than 9, okay? Then I'm going to rewrite this so that my x's are going to be next to each other, so that way you can smush it all together. So if x is bigger than 0, that means that 0 is smaller than x, okay? And x is less than 9. So then putting it all together, it means that 0 is less than x is less than 9. Now I can go ahead and graph out my information right here. So my smallest number is 0, so I'm going to go 1 to the left of it. So I'm going to start at -1, and I'm going to go all the way up until I get to 1 to the right of my largest number, which is 9. So I'm going to stop at 10, okay? Right here, 8, 9, 10. Now, if x is bigger than 0, then I would put an open circle on the 0, and I would go to the right. Again, I'm trying to see where they overlap. That's why I'm doing it on top. And if x is less than 9, I can start at 9 right here, and it would go to the left, and they would overlap in between. Okay? So then you would end up getting in interval notation 0 to 9, excluding both 0 and 9. Okay? All right, and number 5, graph the solution set of x is greater than or equal to 1 or x is less than -4. So for this question right here, I cannot combine these together because it's an or problem. When I do this, I'm still going to start it out the same way we started all of our other questions out. So I'm going to go from my smallest number to my largest number. The smallest number is -4, so I'm going to go 1 to the right of -4, and I'll start at -5, and I'll go all the way up until I get to 1 past 1, which is 2, okay? Now, if x is greater than or equal to 1, it says or, so only one of these has to be true. So guess what? I don't have to see where they overlap. I can go right to graphing it out. So no overlap is necessary for or. Okay, and then we'll do the same thing with x is less than -4. I would start right at -4, and then I would go to the left because it's less than, and again, same thing, no overlap is necessary. So now, how do I write this out in interval notation? Well, in these examples right here, we only had one section. It was from -2 to 5. Or it was from -4 to 2, right? But in this example, we have two different sections. We've got our purple section and then we've got our red section. So we have two different intervals that we have to write out. The first interval started all the way at -infinity and it goes to -4. Okay, so it's -4 and below. So what we would say is it's from -infinity to -4. Now remember, we put an open bracket around -infinity because you can never reach -infinity, okay? And then we'll close our bracket here. We'll have an open set of brackets right here. So this will be -4 with an open bracket. And then what we're going to say is, or this right here, this means union, but it just basically means or. And then our other answer right here would be from 1 all the way to infinity. And I put a closed bracket around the 1 because it's equal to 1. Okay? Now technically you would write this all out as one line, but I just don't have the room for it. Okay? All right, so now let's look at question number 6. This is where things get a little bit tricky. Put your thinking hats on right now when you're doing this. Really think hard about what you're doing, okay? So the smallest number we have here is 2, so I'm going to go to 1 to the right of 2, so 1 to the left of 2, which is 1, and I'm going to go all the way past 5. I'll go 1 past 5, and I'll get to 6, okay? So now, this is an and, so an overlap is necessary. So I'm not going to shade it and write it on the number line yet, just until I see where they overlap with each other. So x is greater than 5 means it'll go this way, okay? And then x is less than 2 means that it should go this way. Now, when is a number, when are the red and the blue going to intersect with each other? They're never going to overlap with each other. So what can you conclude about that? That means that there's no solution. Okay, so there's no possible answer because there's no way, think about it logically. Can you find a number that's bigger than 5 and smaller than 2 at the same time? No way, it's impossible, okay? So now let's look at number 7. This time it's or. So since it's or, I do not have to see where they overlap with each other. So I'm going to go 1 to the left of my smaller number, which is 4. So I'll start at 3. And then I will go all the way past 7 to 8. Okay, now if x is less than or equal to 7, I would put a closed circle on the 7 and I would shade in everything to the left of 7. Okay, then it says or x is greater than 4. So I'm going to put an open circle on the 4 and I'm going to shade everything to the right of 4. Notice how every single possible number is shaded in. So we have infinite solutions. X could be any real number. Remember, real numbers we learned about in class. Any real number you can think of will satisfy this compound inequality. And again, think about it logically. Every single number that exists is either smaller than 7 or bigger than 4. You just can't find a number that's not going to satisfy it. So in interval notation, we're going to say it starts at negative infinity and it goes all the way to positive infinity. All right? All right, now let's take a look at page 5. Write a compound inequality for the solution set shown below. Now, since it's going from one section to another section, and it's only one spot that is shaded in, it appears to me that this is going to be an and problem, okay? So this one means that x has to be greater than or equal to, because it's going to the right of -1, okay? And x has to be, it's going to the left of the 2, so it has to be smaller than 2, okay? Or, that's one possible answer I could say. If it's an and problem, I can also just combine everything together, so I could just say -1 is less than or equal to x is less than 2. Remember, this means x is greater than or equal to -1, and this means x is less than 2, all right? Next one, write a compound inequality for the solution set shown below. This time they're going two opposite directions, so there's no way that a number could be in this section and in this section at the same time, so this has to be an or problem. So x is smaller than 7, right, because it's an open circle and it's going to the left of 7, or x is greater than or equal to 11, okay? All right, number 10, solve the following compound inequalities, then graph the solution set. So what I'm going to do is I'm going to see my problem here and I'm going to split it up into two separate inequalities so I can understand exactly what I need to do for them. So the first inequality will start right at 20 and I'm going to keep going until I see my next inequality sign. See how there's one right here? So here's my first sign. This is for my first problem. Once I get to my second sign, it means I stop right before I get to it. So my first inequality would mean 20 is less than -3x plus 11, okay? But I also have to have my second inequality. Now, since it's stuck together, it's an and problem. So my second inequality would be -3x. I would start right after that first inequality sign. So it'd start at -3x and it would go all the way to the end. So -3x plus 11 is less than or equal to 29. All right. So then I just have to solve my inequalities. So here, in my first one right here, I would subtract 11 from both sides and I would get 9 is less than -3x. Okay. Then I would divide both sides by -3 and I would get -3 is greater than x. All right. And all the way down right here, I got to do the same thing for this problem over here. So I'd subtract 11 from both sides. I would get -3x is less than or equal to 18. Divide both sides by -3. I get x is greater than or equal to -6. Don't forget that in both of these, since we divided by a negative, we switched our signs. Your final answer requires the word and in it, or you could write it out as a full one compound inequality mixed together. So I could say -6 is less than or equal to x is less than -3. Okay, either one of these is perfectly acceptable as an answer. Now what I need to do is I need to graph out my number line. Okay, so my smallest number is -6, so I'll start at -7. My largest number is -3, so I'll stop at -2. And I would shade in -6 and x is bigger than negative 6, so we would go to the right of negative 6. And then I would also put an open circle on negative 3, and I would shade in to the left of it, so everything in between is what works, okay? So that's my solution. Now I'm going to do a check on my calculator. So you need to open up a calculator document in your calculator, and you can check any number that's in the shaded area. So for me, for example, I'll just check negative 4.2 because it's in the shaded area. So what I'm going to do is I'm going to type in negative 4.2, and then I'm going to store it in, control store as x like we've always done, press enter. Okay, then I'm just going to type in my inequality, all right, the original problem. So the original problem says, 20, so we'll type in 20, is less than. Now, how do you get the less than button? You press control equals and you have all sorts of choices for inequality signs. So here's the less than button, negative 3x plus 11. And then I'm going to do again is less than or equal to 29. Press enter, it tells me it's true. So I know for a fact that negative 4.2 works. Again, it's impossible for me to check every single value, mainly because there's infinite solutions. But what I suggest you do is check a number that's not in the shaded area, and you should get false, and check another number that's not in the shaded area, so you've covered every section, at least one example from every section, so you can be a little bit more confident that you have the right answer. So for example, negative 7 is not in the shaded area, so I'm going to control store that in as x, and then I'm going to press the up button and press enter so I can copy and paste it in. It's false, and we want it to be false, right? Now I'll try maybe like 100. 100's way down here, okay? Again, you can try anything you want that's in that area. So I'm going to say 100, store it in as x, enter. I'm going to go all the way up, enter, enter. It's also false. So I feel more confident now that my answer is correct. All right, last question, number 11. 5m minus 7 is greater than 13, or 5m minus 7 is less than or equal to negative 22. So I'm going to solve each one separately. So this one I would add 7 to both sides, and I would get 5m is greater than 20. Then I would divide both sides by 5, and I would get m is greater than 4. Okay? And then for the other one right here, I would add 7 to both sides, so I would get 5m is less than or equal to negative 15. Divide both sides by 5, and I would get m is less than or equal to negative 3. Do not forget your or in your answer. Okay, so m is greater than 4 or m is less than or equal to negative 3. Now let's go ahead and graph it out. Since it's an or question, I do not have to see where they overlap. The smallest number is negative 3, so I'll start at negative 4. The largest number is 4, so I'll end at 5. Alright, if m is greater than 4, I would put an open circle here, and I would shade in to the right, okay? And if m is less than or equal to negative 3, I would put a closed circle right at negative 3, and I would shade in everything to the left. Okay, so then right here, this means that everything from negative infinity to negative 3 will work. And then remember, we're going to put our union sign, which means or, okay? And then we'll say that everything from 4 to positive infinity will work. And I apologize, I made a mistake right here. This right here should be a closed bracket because it's equal to 3. So I'll have a closed bracket right there. Also, I forgot to go over the interval that you should have gotten for question number 10. It starts right at negative 6. And it includes negative 6, and it goes all the way to negative 3, but it does not include negative 3. Okay? Hopefully that makes sense to you. If you have any questions, make sure to let me know.